So what are the 6 things a mold maker needs to think about when they're buying a control or a machine with a specific control? First one is spatial plane. This is a nice feature, specifically if you want to do 5-sided machining. It allows the operator to just use one simple program and then use the spatial plane function to move around the 5 sides of the mold. So using the same program, just changing the planes. I'm coming from the Z, I'm coming from Y, I'm coming from X. And you can basically use the same program and machine that part on 5 sides. Number 2 is the contour mitigation feature. This feature allows you to really optimize your speeds and feeds without being at the machine. You're basically allowing the machine tool to run the toolpath within precise tolerance band, like a racetrack, right? So if you want to go very close to a corner to speed up as quickly as you can use this function, and the machine will automatically adjust the speeds, read ahead of what points are coming in the program, and optimize the behavior and the motion around the corners to maximize the speed in this application. So number 3 is linear encoder capabilities. What you want to make sure of is that your control is able to interface with linear encoders, because linear encoders on all axes guarantee maximum positioning accuracy. You don't rely only on a rotary encoder that is mounted on the ball screw. You want to know exactly where your machine is at any given time, and that's why you need linear encoder technology. So if the control is not capable of doing it, you will have very difficult times to make a high precision part, specifically have a longer travel or have your larger machine tool. You will precisely position the machine utilizing linear encoder technology to do that. Number 4, vibration mitigation. So that's another nice feature specifically for mold makers. And as we all know, we like to get as much material removed as quickly as possible. The downside on that is sometimes we're overloading our spindle, we're overloading our cutting tools, and that can create some harmonics in the machine. In the start, the machine starts to vibrate, what then also be reflected in your workpiece, or it can even break your tool. With this new control feature, your control should be able to sensor this vibration and slow down the machine to take these harmonics out of the machine tool itself, slow down or speed up depending on what it is, so you don't create any type of vibration on the cutting tool or you're damaging your surface finish because you're overloading the spindle and you're creating these vibrations. So very important part for the mold maker. Number 5, operator flexibility. And I think that's very critical in today's world, because we're looking for more and more operators and younger operators, the next generation operators. So you want to allow the operator to have a certain flexibility on the machine tool without just relying on the CAD/CAM program to bring the program in and the guy just pushes a button. You want to have a certain flexibility within the setup, or you want to have a certain flexibility to do something right on the control, utilizing a touchscreen technology maybe to look into a specific detail you want to machine, or there's maybe something what was missed in the program where the operator can make a quick change right on the control. There's a hole missing, you have to drill and tap it maybe. You can do that right on the control, he can do that right on the control. You need to have that flexibility, otherwise you have to go back to the programmer, get that all reprogrammed, load the program back into the machine to drill this one hole, versus the operator can do it right on the fly. So the control needs to be able to allow you this flexibility, and it has to be easy and intuitive to do that. That will be very important. So last but not least, number 6, automatic feed control. What is very important also for the mold making industry. If you look at what a lot of mold shops do, if they have a larger mold and they have to remove a lot of material, they take that big mold on a bigger machine, they're roughing out the material, and they leave certain stock around certain areas. And then they take that machine maybe into a full 5-axis high-speed milling machine. The problem with that is you never know exactly how much stock you have in each area. That means it's very difficult for the programmer to have the right speeds and feeds at any given time. So if you have an automatic feed control, the control will be able to look at the spindle load and the engagement of the cutting tool when you're machining that part. That means the control will automatically adjust the speeds and feeds without you being there to do that for you. So if there's a lot of material in a corner, the machine will automatically slow down, protect the tool, protect the spindle. And then when there is not so much material or you're cutting air, the machine will automatically speed up to the maximum speed what is allowed for that type of application. So that gives you really a peace of mind to run the machine very efficient and getting the good results and good surface finishes mold makers need and want to be having to stay competitive. There's a good example for a very good mold shop up in Canada, Windsor Mold, a user of a lot of height 9 controls, and they used to be not a height 9 user. But there's a little story to this. They walked through a show and they are walking by a machine tool, and all of a sudden they hear this noise and it sounds like vibrating and the machine doesn't sound right, and all of a sudden the machine slowed down and this vibration went away. So the guys from Windsor Mold turned around and went into this booth and they saw a machine with a height 9 control, and they looked at it and they said, how can this be? How can the machine really adjust on the fly by itself to take this vibration out? And that's why they decided to buy a machine with a control, and they did a test before they did this, and they used basically the ACC, what is taking the vibration out, and connected it with the AFC, the automatic feed control, to see how that really would work, so they could get the efficiency, slowing down the speed process or the speed of the machine when there's not enough material there, or speed it up. And they combined these two features together, and they did some tests, and they found that they could improve their productivity, and they get their surface finishes, and their reliability and their tool life increased quite a bit utilizing these two features together. And that's when they decided to basically put all controls on the height 9, or height 9 controls now on all of their machines. So really good case history. So if you want to talk to them, that's a real mold maker, and they probably can tell you much more than I can. But that's a real example to do these 6 things, and the last 2 were critical for Windsor Mold. So check them out and make sure you look at that before you buy your next control.